All right, so when you take a derivative of a logarithm, we're going to do it in the special case first. And the special case is the derivative of ln of x. The derivative of ln of x is 1 over x. Now, one of the things that makes this derivative interesting is that the answer is x. It's basically x to the negative first. Okay, and if you think about how we get derivatives, we always use one power below what we started with, right? Okay, if you have a quadratic function, x squared, that derivative is x to the first. If you had x to the fifth power, then that derivative would be an x to the third power, right? So you're always lowering one, okay? So the question is, what would you have taken the derivative of in order to get x to the negative 1? Well, going one power back up, it should have been x to the 0. But x to the 0 is a constant, right? X to the 0 is 1, and the derivative of all constants is 0. So up until now, we didn't really have a way of getting a derivative that resulted in x to the negative 1 power. The log function fills in that gap. Okay? So the derivative of ln of x is 1 over x. Find y prime if y is equal to the natural log of x plus x cubed. So y prime is equal to the derivative of the natural log function, which is 1 over x, plus the derivative of x cubed, which is 3x squared. All right, example 2. Find y prime if y is equal to the natural log of 7x. So this one is going to involve the chain rule, because you're taking the derivative of not just the natural log of x, but it's the natural log of some other function, right? So we start in the same format. The derivative of the natural log function is 1 over, and then it's whatever you're taking the whatever the argument is for the natural log. So it's 1 over 7x times the derivative of the inside, which is 7. And then what happens with the 7s? They cancel. And it is actually 1 over x. So it's actually the same as the derivative of the regular log. Now there is an algebraic argument that you could use to show that this should work out the same way. Let me briefly talk about that. The natural log of 7x is really the natural log of 7 times x. And you know that if you have multiplication inside a log, you can split that up with addition. Okay. So then if I take the derivative, then the derivative here, well, the derivative of the natural log of x is 1 over x, and the natural log of 7 is just a number. It's, whatever number that is, it's probably around 2 something, right? And the derivative of a number is just 0. So this is 0 plus that, which is just 1 over x. Okay. So it makes sense to have this be the same thing.